Suppose you had a bunch of DVDs at home that you wanted to arrange them neatly. What would be the ideal choice for storing such a thing? You could find a cardboard box big enough to arrange all the DVDs neatly, right? It's as simple as that. However, you may also want to add new DVD into the box, or you may want to get rid of the older ones that you may watch a million times over in the past. An important consideration for this box would be that you would only place DVD in it and nothing else. You wouldn't place your clothes in it. For example, the box would contain multiple items, but all of them would be in the same type. In this case, the type is DVD. Items of the same type, they share properties. For DVDs, those properties include all DVDs should be inside a plastic cover, and the cover would have the name of the new movie, the cast, and all sorts of other details. And the cover would be exactly the same size, would contain only one DVD. You may not actually name the DVD box, but when you want your sister to fetch the DVD, you tell her that the DVD is inside your DVD box, and she would instantly know where to find the box. And this is a very simple yet realistic scenario that is easy to understand and relate to. So let us move over to the world of computers and port this example to programming. Suppose you are told that you need to build some software to keep track of all the DVDs in an inventory. And this is exactly the same scenario that we need to describe above, but on a much larger scale. So let's imagine the DVD box as a virtual DVD library. For each DVD, you would have a certain properties that would be a specific attribute of the movie themselves. In addition to the properties of the DVD, you also told that the maximum number of the DVDs that can be stored in the inventory. Obviously, you wouldn't want to store the ancient movie from the 1900s unless they were popular ones, right? Saying you were told that the requirement is to maintain a maximum inventory of just 100 DVDs. This is an important piece of information, because without this, you wouldn't be able to find the perfect size box to fit all the DVD easily. How could we find a box of a particular size that could be able to fit a maximum of 100 DVDs? Well, luckily for us, we don't need to physically find a cardboard box or anything. This is a programming constructor for this purpose. That programming constructor is known as an array. An array is a collection of items. The items could be integers, strings, DVDs, games, books, anything really. The items are stored in neighboring contiguous memory location. Because if they stored together, checking through the entire collection of items is straightforward. So how can we relate this back to the physical DVDs? Well, do you keep all your DVDs all around the house in multiple locations? Of course, hopefully not. Most people keep all of their DVDs right next to one another inside one gigantic box, or perhaps on a bookshelf. We do this so that if we want to find a particular DVD, we can quickly search through all of them without running from room to room. So how do we create an array on a computer? Arrays can hold up to n items. The value of n is decided by you. You are the programmer to create an array. This is the same as when we find a big enough cardboard box for the DVDs. Additionally, we also need to specify the type of the item that will be going into the array. So let's try to create a array, DVD array, and called DVD collection. A new DVD 15, and we need to give them a class, public class DVD, and inside the class we need to give them a simple definition, public string name, public integer release year, public string director, and public DVD string name, integer release year, string director, and inside is this dot name, this dot release year, this dot director, and we are done. And give them two string, public string to string, return this dot name plus directed by blah blah, and plus this dot director, and plus released in blah blah, this dot release year. Okay, we are done. And so now this 15 is the peak memory is like 31. If we add more, it will occupy more memory, right? More memory. Wow, too much memory. More memory. Wow, 400. Wow, 1.5 G. Wow, beyond is an error. At the start, there are no DVDs in the array. We will have to actually put them in. The array can hold up for 15 DVDs, but if we get the 16th DVDs, we need to make a new array. We'll look at how we deal with running out of the space in the next chapter. But before we move on, actually putting some DVDs in the array, though one thing you might be wondering is, why would we make an array with only 15 places? Why not we just make it hold 1 billion DVDs, so that we can know for sure we will always have enough space? Well, the reason is the same as it for the physical box of DVDs. Do you really want to find a box that could hold 1 million DVDs when you currently only have 15 DVDs and, in fact, never expect to own more than 100 of them? It's even worse getting a box that could hold 100 DVDs right now, when you only expected to get a few new ones each year. So it will take up more space in your home and in the minimum time, right? It's exactly the same with the array, where the space in your home is analogous to the memory of the computer. If you make an array with 1 million space, your computer will reserve memory to hold 1 million DVDs. Even if you put 15 DVDs into it, that memory can't be used for anything else in the meantime, just like the space in your house that has been taken over by that huge cardboard box.